All right, so in this topic, we're going to be talking about functions and symmetry, as well as the terminology for these things. So first of all, just to give us an idea of what's going on, I will go ahead and throw up some example graphs here. Keep in mind that the functions we're going to be talking about don't all have to look like this. They could look like anything, because we're going to be working more so with the formulas themselves. But say I had a graph that looked like this. Well, something you may notice about this guy is that if I have a point over here, let's say this is x1, I have that exact same point, or not the same point, but I have a very similar point over here where this x value is what I have there, but negative. So I could call it negative x1. Get rid of that. And then what happens is up here, the y values did not change. So I have negative x1, comma, some y, and then positive x1, comma, some y. So what's interesting about this is a more formal way to talk about y symmetry. So if you see here, the y-axis, if I were to take this graph that I drew here, assuming I had drawn it more perfect, and I were to flip it like this along the y-axis, you can imagine taking this and just spinning it, I would get the same thing after doing that, right? If you can do that visually, that means you have y symmetry. Now, what if you don't have a graph? What if you have a function? Well, that's where it gets interesting. So you can look at this and you can go, okay, what happens when I say that I can flip something on the y-axis and I get the same thing? What's going on? Well, what's going on is everywhere you have a point of x comma y, on the other side of the y-axis, you've got almost the exact same thing. You've got negative x comma that same y. So if we had actual numbers here, this would be like if this was negative 3 and 3, and then this could be the point 3 comma 9, and this could be the point negative 3 comma 9. And perhaps you may notice that this graph is f of x equals x squared. And so what's happening is every time you've got any number, you have both the negative and positive ones giving you the same output. And so that gives you y-axis symmetry. That is also called being even. Now, what if you don't have a graph? Well, what's cool is that the definition of even says that if you have f of x equal to f of negative x, right? If the function given a positive value is the same as a function given the negative value, then that means you're even, and even just means that you're y-symmetric. So, an example, let's say we have the function f of x equals 3x to the fourth plus x squared minus 7. And we're asked, is this even? Well, what we can do is we can just plug in negative x and see if we get the same thing. So this is going to become f of negative x equals 3 times negative x to the fourth plus negative x squared minus 7. Okay, well now, negative x to the fourth, let's skip that for a minute and look at this. Negative x squared. Well, if I square a negative number, negative times a negative is positive, and so I'm still coming out with positive x squared. And this negative 7's on the end here. Okay, so the reason I went over here is now we're going to look back at this negative x to the fourth. This is the same thing as taking negative x squared and squaring it. Or if you like, you can say you're going to multiply this 4 times. So you're going to do a negative times a negative, which is positive, negative times a negative, which is positive, and then positive times a positive, positive. So we get 3x squared. Well, if you look at that, 3x squared plus x, 3x to the fourth. But if you look at that, we have 3x to the fourth plus x squared minus 7. That's equal to f of x. That's from our original function. That's what we started with. So we can say that f of negative x is equal to f of x. And when we do that, that means it's even, which means it's y-symmetric. So that's how you would show that something's even. Now, another example that can go on is you can have a graph that's odd. So here's an example visual. It's my best attempt at drawing f of x equals x cubed. And so what odd means is the same thing as saying that something has origin symmetry, which means that if you were to cut a diagonal line across here and then rotate along that, and sometimes this can be really tricky to see, you get the same thing. Algebraically, what's going on is, say you've got a point here. Let's call it x, comma y. Well, if this is origin symmetric, I should have the same point down here, but precisely negative. Negative x, comma, negative y. So everywhere I've got a point over here, I should have another one exactly across from it on a diagonal. So that's a lot harder to visualize, but that's what it means to have origin symmetry, that you're symmetric about the origin, and it's also what it means to be odd. So if I want to show that something's odd, all I have to do is show this, that negative f of negative x is equal to f of x. So this looks a little scarier, but it's not that bad. So let's look at an example of one that you can show to be odd. So say f of x was equal to x cubed minus x to the 7th. Let's look at that guy. Well, if I want to plug in values here, I'm going to have f of negative x, and then keep in mind we actually want to show that negative f of negative x comes out the same. So I'll put a negative right there. And to make sure I don't make a mistake with this negative, when I write down my function, I'm going to put it inside parentheses, because I need to put a negative in front of that whole thing. And so then this is going to be negative x cubed minus negative x to the 7th. All right, cool. Now, I'll leave that negative on the outside. If I do, remember we're cubing this, so if I do negative times a negative, that gives me positive, and then times a negative, still negative. So this will be negative x cubed. Okay, then we're going to do minus. Okay, so now I'm doing negative 7 times. So basically, if you take a negative number and you raise it to an odd power, you're going to get a negative again. So you can just do negative, negative, positive, negative, negative, positive, still positive, times a negative is positive, that's 5 times, and then twice more. So you wind up with negative, how do I want to write this? Let's leave the negative right there, and then x to the 7th. Okay, almost there. Then what happens is you've got this negative is still on the outside. Negative x cubed. And then negative negative is a positive, x to the 7th. And so finally, if I distribute this negative in, negative times a negative is positive. Negative times a positive is negative. So if you look at that, you see that you've got negative f of negative x comes out to be x cubed minus x to the 7th, which is exactly what we had to start with. So when we did this, we wound up with saying that f of x came out giving us the same thing when we did negative f of negative x. So therefore, this was odd. And that means it has origin symmetry, which means you can flip it across this diagonal and you get the same graph. So that was an explanation of symmetry, the terminology that even means something's y-symmetric, it can be rotated about the y-axis, and odd meaning that something has origin symmetry or can be flipped across a diagonal line. And that was this topic.